Good afternoon, dear participants of the sixth International Conference on Computer Science, Engineering and Education Applications. I would like to present you our paper on topic Machine Learning for Unmanned Aerial Vehicle Routing on Rough Terrain by PhD Associate Professor Evgen Sidenko, Master of Computer Science Artem Trukov, PhD Associate Professor Alina Kondratenko, Doctor of Science Professor Yuri Zhukov, Doctor of Science Professor Yuri Kondratenko from Petromagila Black Sea National University and CJOP Nikolaev. First of all, I would like to tell you about relevance of this problem. Machine learning, including neural networks, helps unmanned aerial vehicles to move more accurately and positionally on rough terrain, detect and classify objects with a camera and bypass them, adapt to changes in weather conditions based on training models and traffic scenarios, and also deliver different medicines, essential goods in locations with increased risk to human life and more. Currently, there are many areas where unmanned air vehicles have proven themselves well. For example, photography, agriculture, farming, redesign studies and control of construction objects, goods delivery, monitoring of long objects, transportation of medicines and essential goods, and so on. Let's consider the purpose and objectives of the work. The main problem in this task is the choice of the effective use of machine learning for unmanned aerial vehicles routing in rough terrain. In addition, the problem also lies in the need to create a training environment for training and testing the operation of the UAV and then modeling obstacle avoidance situations in conditions close to reality. So the existing works didn't provide a comprehensive solution to the problems of UAV routing on rough terrain. In this work, the authors try to solve these problems using reinforcement learning and game engine Unity 3D. And the main purpose of this paper is to describe the process of machine learning and also developing a system to ensure efficient routing of unmanned aerial vehicles on rough terrain, which will allow more accurate movement of a certain route and increase flight stability. Let's consider methods of machine learning for UAV routing. Use reinforcement training where the machine is facing a task. There are many possible options for performing the task correctly in the external environment, such as computer games, trade operations, and unmanned vehicles. Reinforcement learning is almost the same as learning with a teacher, but the role of a teacher is the real or virtual environment. The same principle applies to reinforcement training. The robot is created in a maze, and it must find a way out. In the process of searching, the robot receives information about where there is no way out of the environment to learn about the world around and learn to find a way out. The main libraries for creating artificial intelligence models supported by the Unity game engine are Code.NET, Microsoft Cognitive Toolkit, TensorFlow, and Unity machine learning agents. Let's consider some methods of machine learning for UAV routing. SARSA is a special algorithm of machine learning with reinforcement. The name of the algorithm reflects the fact that the main function for maximizing the value of Q depends on the current state of the agent S. The action that the agent chooses A, the rewards are that the agent receives for choosing an action, the state S2 to which the agent goes after this action, and finally, the next action A2, which the agent chooses in his new state. The SARSA agent interacts with the environment and updates policies based on actions taken. The value of Q for a certain action and state is updated by the alpha score. The value of Q represents the possible reward obtained in the next time step for performing action A in state S, plus the future reward obtained in the next observation of the action of the state. Q-learning is a learning algorithm used in the field of reinforcement learning. It doesn't require an environment, and it solves problems with stochastic transitions and rewards without requiring adaptation. Q-learning uses an action value function or strategy. Experiments and results. The following class diagram was developed. It determines the types of system objects and various static relationships that exist between them. And you can see the following class diagram in figure 2. To solve the problem of drone routing, a training environment was created, and also you can see it in figure 3. An important task was to force the agent not only to move sideways and forward or backward, but also to rotate the body when necessary, for which the first segment of the environment is responsible. Instead, to create the effect of rising and falling, section with special vertical obstacles was created, and you can see it in figure 4. With the help of vectors, the agent will observe the environment. A total of 17 vectors were used. The proposed neural network structure marks 19 neurons in the input layer, 128 neurons in 2 fully connected layers, and 4 neurons in the output layer. It is shown in figure 6. And to speed up learning and improve its quality, 4 agents have been created who use the same brain to make decisions, but 2 of them are moving in the opposite direction. The input are 17 observable vectors, endpoint position, and drone position. The output are discrete numbers, one for each axis of motion. To move a more realistic environment, a prototype city with a central park in the middle was created, and you can see it in figure 7. In order to specify the endpoint, an empty object was created and located at the end of the road, thus transmitting the exact coordinates of the destination. The maximum height is set in the settings to avoid flying over all obstacles from above. As conclusions, I would like to say that during this work, a drone routing system was designed using machine learning methods, which provides high efficiency and stable flight in rough terrain. The result is a comprehensive system that allows you to perform neural network training with custom parameters for your own purposes, or use an already trained and developed model of artificial intelligence, which is provided by default in the drone model. A neural network architecture with reinforcement learning algorithms was developed, which was successfully implemented in a test model for routing an unmanned aerial vehicle on rough terrain. The test results showed that the unmanned aerial vehicle successfully avoids obstacles in the new environment. Thank you very much for your attention.